Okay, today's lesson is on circle geometry. And so we're just going to go through and quickly review some of the terminology in circles, as well as learn some of the new terminology for circles. So the center here, we name circles by using the capital letter associated with the center point. In this example, this circle would be called circle A because the center is called A. Radius, which we already know, that's the line drawn from the center of the circle to the end of the circle. That forms the radius. The diameter is a line that's drawn from one point on the circle, it's through the center, and then it's to the point on the opposite side of the circle. All right, that is the diameter. A chord is different because it's not going through the center of the circle. So it's any line segment that has both endpoints on the circle, but it's not going through the center. If it was going through the center, then it would be the diameter. This is a secant. It's a line that intersects the circle at 2 points, and this is called an arc of a circle. It's any part of the circle itself. The sector, shown here in black, that is any part of a circle bounded by 2 radii and the intercepted arc. So there's the arc, and this is a radius here, and this is the radius here as well. A tangent is a line that touches a circle at 1 point. So it's touching the circle at just 1 point here. Okay, and this straight line here, but it's circling the circle only at a 1 point there. Next, we are going to look at angles within a circle. So there is an angle that is called the inscribed angle. The inscribed angle, it's an angle formed by 2 chords from a common endpoint. So this here is the inscribed angle. There's the common endpoint, and these are the 2 chords. The central angle is formed by 2 radii. All right, this is represented by M. This center of the circle here is represented by M. So we have radius and radius. So a central angle is always formed by 2 radii. This here is the central angle. We talked about an arc already, which is a portion of the circumference of a circle. We talked about a chord already. This is a chord here, a line segment with both endpoints on the circle. It is not going through the center. And a property to remember here of these angles is that the central angle is always twice the inscribed angle. So this here is the central angle. Notice that it's 2x. This is the inscribed angle represented just by x. Okay, so that's how you could figure out if you were given an inscribed angle, you can figure out the if you were given the inscribed angle, you can figure out the central angle by multiplying by 2. If you are given the central angle, you can figure out the inscribed angle by dividing by 2. Okay, so here again, just looking at terminology first. So we have a point here A and a point here B on that circle. So that makes a minor arc. This smaller portion, that's the minor arc, AB. And then the longer portion around, that is the major arc, AB. And again, the central angle in this situation, this is the central angle formed by joining those endpoints of an arc, so A and B, to the center of the circle. That makes a central angle. So angle AOB is a central angle. Notice that the endpoints are still the same, A and B, for the inscribed angle. Okay, so the angle formed by joining those same endpoints of an arc to the point on the circle, that makes the inscribed angle. So ACB is an inscribed angle. And we call it subtended. So the inscribed and central angles in this circle are subtended by the minor arc AB. So you're going to hear that term a lot, subtended. Okay, these are showing congruent circles, shown by the double dashed line here. Okay, so these are congruent circles, and when the arcs are the same length, so this arc, and this arc, they're all the same length, the inscribed angles will always be the same. So as long as the arc is the same, these inscribed angles will be the same. 1, 2, 3. These three are the same as this one, The next property or rule here is that when the inscribed angle is formed by a diameter, the inscribed angle will always be a 90-degree angle. All right, so notice here, it's the diameter. It's going right through the center. So therefore, this inscribed angle will be 90 degrees. So anytime it's formed by a diameter, the inscribed angle will be a right angle. Okay, so shown here as well, This is going through the center, it forms the diameter, and in these cases, this M represents the center of the circle. So M, M, and M. All right. Okay, so this first property, the central angle and the inscribed angle property. So in a circle, the measure of a central angle subtended by an arc is twice the measure of an inscribed angle subtended by the same arc. So we've already talked about that. So the central angle here is this one, POQ is the central angle, right? So that would be 2 times the subtended angle, the inscribed angle, which is shown here. That's the inscribed angle, which is PRQ. All right, so again, if you know one of them, you can figure out the other one. Okay, this was a property we've already talked about as well, which is the inscribed angles property. So in a circle, all inscribed angles that are subtended by the same arc are congruent. All right, so in this case, PTQ, PTQ, PSQ, and PRQ, they're all subtended by the same arc, this arc here. So therefore, these inscribed angles will all be congruent or the same. All right, and then we talked about if the two arcs formed by the endpoints of a diameter are semicircles. So this is a diameter, it forms a semicircle, half circle, half circle. Then the central angle is 180. Therefore, this angle, which is the inscribed angle, will be half that, which is 90 degrees. All right, so that is what we saw already. Okay, this is just showing that same property, the angles in a semicircle property. So again, this is the diameter. So therefore, these angles, for the inscribed angles, they will all be 90 degrees. So the angle inscribed in a semicircle will be a right angle. All right, so let's take a look at some examples here. So in this first example, again, this M represents the center of the circle. We are given the central angle. We have to figure out the inscribed angle, and we know that this is twice, the central angle is twice the inscribed angle, so therefore we can divide 68 divided by 2 to give us the angle x. So in this case, x, we would take 68 divided by 2, which gives me 34 degrees. All right, in this example, we have, again, we're given our central angle here. Central angle, because we have the center of the circle here and the 2 radii. So this angle here is 90 degrees. So this angle, which is the subtended angle, so notice again, I'm sorry, I keep saying subtended. This is the inscribed angle, and it is subtended by the same arc as the central angle. So therefore, the inscribed angle here would be half of 90 degrees. So x is equal to 90 divided by 2, which is 45 degrees. All right, in this example, point O here is the center of the circle, and we have to determine the values of x and y. We are given one inscribed angle here, and notice that they are all subtended by the same arc, AB. So since ADB and ACB are inscribed angles, so ADB as well as ACB, they are inscribed angles subtended by the same arc, arc AB. Therefore, they have to be congruent. All right, so this is 55 degrees, and so therefore x has to be 55 degrees as well. All right, so x is 55 degrees. Okay, and then y is a central angle because this was a center, right? These are two radii. So therefore, the central angle, which is also subtended by the same arc, the arc of AB, therefore it will be twice the inscribed angle. So our y is equal to 2 times 55 degrees, so y is equal to 110. All right, so let's take a look at this next example. So we have triangle ABC. Triangle ABC is inscribed in a circle. The center is here. The center is O. We are told that AOB, so AOB, this angle here is 100 degrees. And we are told that COB, so this angle here is 140 degrees. And we need to figure out X, Y, and Z, the angles there. All right, so the first one we can figure out easily is X, all right, because we have three angles here forming a circle here. So the sum of the central angles in a circle would be 360 degrees. So just take 360 degrees, subtract 100, subtract 140, and we'll get 120 degrees for X. So X is equal to 120 degrees. So we have that one. Next, let's look at Y. Y is here, and it is an inscribed angle, angle ABC. It's an inscribed angle, and we just determined X here. That is a central angle, angle AOC, and we just figured it out. We just figured out that it was 120 degrees. So that's a central angle right there. So therefore, Y would be half that. So half of 120 degrees is 60 degrees. So that gives us angle Y here as 60 degrees. The last one is Z. Angle Z is here. Okay, it's just this angle here. So AOC is what we're looking at, or angle Z, not AOC. We can call it ACO, as long as the C is in the middle when we name that angle. So what we know to figure this out, we know that these are two radii. This is the center, this is a radius, and this is a radius as well. So because it's a radius and a radius, that makes an isosceles triangle. That means this line, which is a radius, this is the radius, they're both the same length, so therefore it is an isosceles triangle. We know that the sum of the angles in a triangle are 180 degrees, and we already know that angle X here was 120 degrees. So take 120 degrees, divide it by 2, that gives us 60. Take 60 degrees, divide it again by 2 to give us 2 angles here. So that gives us 30 degrees. 60 divided by 2 to give us 30 degrees. So in this example, M is representing the center of the circle, and this line, which is going from one endpoint through the center to the other endpoint, because it's going through the center, that's the diameter. Because it's the diameter, this inscribed angle will therefore be 90 degrees, making it a right-angled triangle. So, because it's a right-angled triangle, and we have two sides here, we can use the Pythagorean theorem. So we're going to use the Pythagorean theorem to figure out that missing side. And my pen is dying here. Okay. All right, so we're going to use the Pythagorean theorem. Right across from the right angle, this is the hypotenuse. So we're solving for the hypotenuse in this case. So we'll use our a squared plus b squared equals c squared. All right, to figure out the hypotenuse. So here we use the Pythagorean theorem to solve for side x. So 14 squared plus 30 squared, that gave me 1096 was equal to c squared. Take the square root of that. We get 33.1 meters for c, which is equal to side x.